Hello, this is Steve. We're going to talk about another one of algebra's basic functions, so thank you for joining me. Even though you see the function f of x equals x cubed up on the board right now, the function we're actually going to talk about in this video is the cube root function. The reason I have x cubed up here is because you really don't want to try and understand the cube root function until you've learned about the x cubed function. So if you haven't watched the video for x cubed, go back and watch that one before you watch this one. If you have watched it, then you'll recognize this graph and these ordered pairs up here for x cubed, and you'll be able to pick up right here with the cube root function. The cube root function actually does the opposite of what x cubed does. It takes an x value and determines the number you cubed to get that value. For instance, if I put a 125 into this function, what it's actually asking me is, what number did you just multiply by itself 3 times to get 125? So the cube root of 125 is 5. And you justify that to people by saying because 5 times 5 times 5 is 125. So it truly is the opposite of the x cubed function. Now, you can actually take the cube root of any number you want, but a lot of cube roots are not answers we know quickly. So I could ask someone for the cube root of 10, but unless you're a mathematical genius, you're not going to know that without a calculator. So need calculator problem. I don't want to tell you you need one, but I would use a calculator on that. So when we plug numbers into this function, we want to make sure we plug in numbers that we know the cube root of. And to do that, we think about what we learned with the x cubed function. We learned with the x cubed function that when we cubed -2, we got -8. When we cubed -1, we got -1. When we cubed 0, we got 0. When we cubed 1, we got 1. When we cubed 2, we got 8. And since this function, the cube root of x, does the exact opposite, we can do something really, really slick. Check this out. I'm going to make a table for the cube root function because it's the opposite of the x cubed function. You just switch the columns for the x and y values. So what we're going to have is over here we're going to have -8, -1, 0, 1, 8. Over here we're going to have -2, -1, 0, 1, 2. Just like that. And this creates a graph that looks like this. And just like the cubing graph, this one can take a little practice to draw. It's not that friendly. So we got 0, 0 there, 1, 1 there, -1, -1. You'll actually notice those first 3 points in the middle there are exactly the same. But now we've got 8, 2 over there, and -8, -2 there. Now this function, and it is truly a function, actually if you look at a picture of it, can look like it fails the vertical line test right here near the origin 0, 0, but it doesn't fail the vertical line test. This is a function. Please believe me, this is a function. But it looks like that. Left and right forever, that's good news. That means our domain is -infinity to infinity. And it does go down and up forever, just very, very slowly. So our range is -infinity to infinity. If you're looking for a more precise way to describe the relationship between the x cubed function and the cube root of x function, we actually say that f of x equals x cubed and g of x equals cube root of x are inverses of each other. That's the key word. They're inverse of each other, or they are each other's inverse function. We'll learn more about that later. All right. Thanks for watching.